Let us take the example of partial differentiation. The question is find the value of n for which u is equal to a e to the power minus gx sine of nt minus gx satisfy the partial differential equation del u del t which is equal to m times of del 2u del x square where a and g are constants. So now how to solve these questions? We have given that u is equal to a into e to the power minus gx sine of nt minus gx. Let us give it equation number 1. Then we have to prove that we have to find out the value of m, value of n we have to find. So now differentiating, what is our aim? Our aim is to find out the partial derivative of u with respect to t and second order partial derivative of u with respect to x. So let us first find the partial derivative of u with respect to t. So now this a e to the power minus gx is constant. What is the derivative of sine x is cos x. Again, derivative of nt minus gx with respect to t is n. So we have written over here, just look here, this a to the power minus 9gx is constant. This is constant. We have to written as it is. Derivative of sine t is cos t and derivative of nt minus gx with respect to t is n. So this is del u del t with respect to del u del t. Now we have to differentiate this u with respect to x, this one. And not only one time, we have to differentiate 2 times. So let us try to first differentiate one time. So here, this is the function of x and this is also the function of x. So we have to use the product rule. First function is e to the power minus gx, or we can take the derivative of e to the power minus gx is minus g a to the power minus gx sine nt minus gx minus, because or we can write down plus what is the derivative of sine t sine nt minus gx, so which is cos nt minus gx, again nt minus gx with respect to x is 0 minus g. So therefore we have written minus g over here. Minus plus is multiply with minus z, so this become minus of g. Now just look here, a minus z is common in both the term and e to the power minus gx is also common. So let us take outside minus z a e to the power minus gx as taken as common. So we have sine nt minus gx plus cos of nt minus gx. Now so partial derivative of u with respect to x is minus z a e to the power minus gx sine nt minus gx plus cos nt minus gx. Now let us try to find out the second order partial derivative of u with respect to x square. So again differentiating u with respect to x, we have del 2u del x square, which can be written as del x of del u del x. Del u del x is nothing but minus z e to the power minus gx sine n sine of nt minus gx plus cos of nt minus gx. Again we have the product of two functions. This is the first function and this is the second function. So again apply the product function, product rule. Okay, so the first part minus z a we have taken outside. Derivative of e to the power minus z is e to the power minus z into minus z. So minus z in minus z will become g square, and this thing is the same. Nothing is changed. Plus again the second part, we want to find out the, this is the first part, we do not want to differentiate it. Derivative of sine nt minus gx is cos nt minus gx into minus z. Similarly, derivative of cos nt minus gx is minus sine nt minus gx into 0 minus gx, 0 minus z. So here again minus z can take outside from both the term. So we have again minus z into g is g square, a into e to the power minus gx. Now after that, sine nt minus gx cos nt minus gx plus, this is common, cos nt minus gx minus sin nt minus gx. So this sin nt minus gx positive and this is negative will cancel. This cos of nt minus gx plus cos of nt minus gx twice. So 2g square into a to the power minus 9x, or sorry, minus gx cos nt minus gx. So now this is the value of second order partial differentiation of u with respect to x. So its value is 2g square into a e to the power minus gx cos of nt minus gx. Now, since u is equal to a e to the power minus gx sin nt of minus gx satisfies the partial differential equation del u del t, there is a m over here, m del 2 u del x square. So putting the values of del u del t and del 2 u del x square in the above partial differential equation, we have del u del t is equal to m del 2 u del x square. So let us try to put all these values over here. Del u del t is n times of a e to the power minus gx cos of nt minus gx, and there is a m del 2 u del x square. This is nothing but 2g square a to the power minus gx cos nt minus gx. So now this cos nt minus gx can cancel, e to the power minus gx can cancel, and so we have a will also cancel. So we have n equal to 2mg square. Therefore, the value of n which is equal to 2mg square. So this is the desired value of n. Thank you.